Hello everyone, my name is Rebekah Havens and I'm a second year Doctor of Audiology student at the University of Texas at Dallas. I want to say first thank you for attending my virtual poster session today. I will be discussing speech and noise recognition by voice-to-text applications. To start off this poster session, I'm going to go over my abstract and then bring you guys into my introduction. So because of the COVID-19 pandemic and the mask mandate, we know that persons with hearing loss struggle to hear in their everyday listening environments due to the absence of speech reading cues that masks take away. So the purpose of this project was to obtain results from 3 voice-to-text applications, including Live Transcribe, Otter, and Dragon Anywhere, that can be run on an iPhone to determine their accuracy in background noise. Overall, the applications performed similarly in quiet, but varied greatly in noise, with the Otter application providing the greatest accuracy. The benefits for speech recognition from visual cues on the face have been studied for many years. Multiple studies have shown that visual cues enhance speech recognition in difficult listening situations. It has been recommended that individuals with hearing loss use voice-to-text applications to assist with speech understanding, especially in difficult listening environments. Voice-to-text applications may also be applied in speech recognition research during a pandemic when safety protocols restrict data collection with humans due to concern of the COVID-19 virus. The purpose of the study was to assess the accuracy of 3 voice-to-text applications: Live Transcribe, which will be called LT, Otter, OT, and Dragon Anywhere, DA, in 3 conditions: quiet, speech noise, and babble noise. Each application was tested with the hint sentence list for in 3 conditions. First is quiet, then speech noise, and then babble noise. Each of these conditions was run 3 times with each voice-to-text application. Responses were scored by word % correct. The equipment and smartphone applications utilized in the study will be shown in Figure 1 and Figure 2. The equipment used in this project included an iPhone X and a Lenovo laptop, as shown in Figure 1. Figure 2 shows the smartphone applications open on the iPhone and also the application icons that are seen on the iPhone. The first, denoted by the red and white elephant symbol, is Live Transcribe. The second is Otter, denoted by the white and blue application. And then the last one is Dragon Anywhere, which is the mobile version of Dragon Naturally. Now I'm going to discuss the setup utilized in this study. All measurements were made in an audiometric sound booth, and the setup is shown in Figure 3. The sentences and speech and babble noise were produced from a Lenovo laptop that was routed to an audiometer and then to 2 speakers inside the sound booth. The hint sentences, or speech in this case, is going to be produced 0 degrees azimuth and 3 feet from the iPhone. The speech noise and babble noise, which is also coming from the Lenovo laptop to the audiometer and then routed to a speaker in the back right-hand corner, will be 180 degrees from the iPhone. The level of the hint sentences, or the signal, was presented at 80 dBHL for each condition. The speech noise was presented at 55 dBHL, and the babble noise was presented at 70 dBHL for each condition. First, I'm going to cover Figure 4, which is our quiet condition. Overall, all voice-to-text applications performed very similar in quiet, with Otter actually performing the best. Again, the hint sentence list 4 was played, and it was ran 3 times, and each trial was scored by word % correct. Now we're going to take a look at the noise conditions. Figure 5 shows the speech noise condition that was used. Again, the hint sentence list score was ran 3 times for each application. Now we know that speech noise is a constant signal with no interruptions, so the applications did struggle to transcribe correctly. I had to raise the intensity of the signal so that it was able to pick it up and still transcribe. Overall, the applications didn't perform as well as expected in speech noise, even though Otter did perform best in speech noise condition, followed by Dragon Anywhere, and then Live Transcribe. Now we look at the babble noise condition. Our applications performed a little bit better, still with Otter coming out on top, followed by Live Transcribe and Dragon Anywhere. Also for this project, I wanted to compare the noise performance for each voice-to-text application. Again, Otter performance was best. When we look at speech noise, Otter performed 92% word correct, and for babble noise, 85% word correct. Dragon Anywhere performed 68% word correct for speech noise and 54% word correct for babble noise. Live Transcribe performed 51% word correct for speech noise and 70% word correct for babble noise. Again, the purpose of this project was to determine the accuracy of 3 voice-to-text applications that run on a smartphone using the hint sentences in both quiet and speech and babble noise conditions. I looked at Live Transcribe, Otter, and Dragon Anywhere. And Quiet, Otter, and Dragon Anywhere performed similarly with 100% accuracy. Live Transcribe was nearly 80% accurate and Quiet. In the noise competition, all 3 applications did better with continuous speech noise than compared to babble noise. Otter showed the best overall performance, reaching 99% accuracy for speech noise. For the babble condition, Otter achieved 85% accuracy compared to the 54% and 27% for Dragon Anywhere and Live Transcribe. Due to the COVID-19 pandemic and the mask mandate, individuals are now asked to wear face masks, which restrict audio and visual cues. The use of voice-to-text applications as a viable solution is supported by this research. Of the 3 voice-to-text applications, Otter yielded the highest accuracy and could therefore be used to facilitate communication during the mask mandate. These results also suggest that voice-to-text application could be used rather than speech recognition research, rather than in-person subject testing. Rather than a person responding to the speech presented, the Otter application could provide the response. More research is needed to determine if results with the voice-to-text application would correlate with human performance across speech recognition conditions that may vary by signal-to-noise ratio or assistive technology type. This research is supported by the National Institutes of Health, National Institute on Deafness and Other Communication Disorders. Here are my references. Thank you for listening to my virtual poster session today. If you have any questions, please feel free to contact me at rebekah.havens@utdallas.edu.